Hello friends, now we will see the next topic of operational amplifier or next characteristic of operational amplifier, that is slew rate. And this topic is very important from examination point of view. You have lot of questions from this topic. So please do remember all the possible expressions from slew rate. First of all, you should know the definition of slew rate. Slew rate is basically the maximum rate of change of output of an op-amp or an amplifier which is obtainable without introducing any distortion in the output. I repeat, please understand the definition. That is the maximum rate of change of output of an op-amp which is obtainable without introducing any distortion in the output. It means the output should have same nature of the signal as input. If input is sinusoidal, it should be output should be sinusoidal. If input is square wave, output should be square wave, and so on. But basically most of the times we talk about sinusoidal signals, right? So I will say the slew rate is nothing but the maximum rate of change of output of the amplifier. You can say op-amp based amplifier. That is nothing but slew rate of the op-amp. Fine. So basically when we define the slew rate, so it will be basically rate of change of output. So we will be able to determine the maximum frequency or maximum amplitude of the signal obtainable at output without introducing the distortion. We will see it mathematically. So let us talk about sinusoidal signals. Suppose I have an amplifier which is op-amp based amplifier. This is what? This is op-amp based amplifier. Fine. So we will be talking about op-amp based amplifier only. So we have input signal Vi and we have the output signal V0. So let gain of this amplifier is A. Gain is what? The gain of this amplifier is A. Right. So I'll be talking about gain A. So the output of this op-amp in terms of input will be what? A into V input. That will be output. Output of op-amp is what? Gain into input. So let input to this, I am talking about now, that is of course a special case, that is for sinusoidal input. I am considering for sinusoidal input. So we assume that Vi is equal to, so let Vi is amplitude of input into sine omega t. That is my assumption. So we have sinusoidal input signal here. So I apply sinusoidal input to the amplifier. In that case, what will be the output? Output will be A into Vm sine omega t. That will be the output of the amplifier. So what will be the rate of change of output? dV0 by dt, that is A Vm into omega cos omega t. What you differentiate it? So that is omega into cos omega t. Now if you talk about maximum rate of change of this, so that is nothing but amplitude of this. So that is maximum is what? That is A Vm into omega. Right? So I hope the concept is clear. Now remember one thing. For distortion free, remember this point, for distortion free output, the slew rate of op-amp, the slew rate of any op-amp should be greater than or equal to the maximum rate of change of output. I repeat, the slew rate should be, this is the actual output, but slew rate should be more than or equal to the maximum rate of change of output. Fine. Although we have defined this, but for distortion free means there is no distortion in the output. If input is sinusoidal, output will be sinusoidal if and only if this slew rate is, remember this, what is the slew rate? Slew rate is given in data sheet of any op-amp. This is fixed quantity or fixed parameter of the op-amp. It is supplied to you with the data sheet of any operational amplifier IC. Fine. But V0 can vary depending upon rate of change of output will be depending upon what actual input signal given to the operation amplifier. So for distortion free output, the slew rate which is given in data sheet should be more than or equal to maximum rate of change of actual output of the op-amp. Fine. So for sinusoidal output, for sinusoidal input, but this is the maximum rate of change of output. So slew rate of operation amplifier should be greater than A into Vm into omega. This expression is very important. So omega is what? You know, omega is 2 pi into f. So slew rate should be greater than or equal to A into Vm, or I can rewrite it like this. That is nothing but 2 pi f into A into Vm. So this is, I will repeat it again, very important expressions. You have a lot of questions based on this topic in the exam. Fine. Now, what could be the possible type of question? That is important. You should be knowing what are the possible questions or possible numericals based on this topic in different competitive exams, maybe GATE, maybe engineering services, and it is very important for all the exams. So you have lot of questions on slew rate, numericals as well as theoretical questions in different exams. So let us see that. Case 1. Case 1 is what? Case 1. I'll be taking 3 cases here. What are the 3 cases? Case 1. Case 1 is what? Case 1 is frequency is given to you. Frequency is given to you and A is given to you. Gain of the amplifier is given to you. Most of the times you will find gain is given. In that case, the amplitude of the input signal should be less than or equal to slew rate divided by 2 pi f into A. That is the limit on amplitude. So amplitude will be less than or equal to this quantity. Case 2. Case 2 is what? That is, now amplitude is given to you. Fine. And A is given to you. In that case, your frequency has to be determined. So max frequency in that case should be less than or equal to slew rate divided by 2 pi A into Vm. Try to remember this. You have a lot of questions on this. This is very important. This is very important. You will find most of the questions on these 2 expressions. There can be third case as well, although there is little possibility on this. What is given? Vm is given to you. Fine. And frequency is also given to you, and you want to find the maximum gain. So gain of the amplifier should be less than or equal to slew rate divided by 2 pi f into Vm. These are 3 expressions. Try to remember, and I will say 100% questions on slew rate will be based on these 3 equations only. I'm talking about the questions from this topic which have appeared in all the competitive exams from this topic, that is from slew rate. So I hope you will remember all these expressions, and now we will see the numericals which have appeared in different exams just for your knowledge and your practice. Fine. So we will now see the numericals based on slew rate. Now let us see the numericals based on the slew rate. The first example is an amplifier using an op-amp with a slew rate of 1 volt per microsecond has a gain of 40 dB only. If this amplifier can amplify the signal up to 220 kilohertz without introducing any distortion, then find out the amplitude of input signal which should not be exceeded to avoid the distortion. So we have to find the amplitude of the input signal which should not be exceeded so that there is no distortion at the output. So you can see the output of amplifier is what? V0 is equal to A into V in, that is A into V in. Remember, we are talking about, if there is frequency, that means we are talking about the sinusoidal signal. So here gain is given in decibels, so we know gain in decibels is what? 20 into log A, and that is 40 dB given to you. So this will be equal to A equal to 10 to the power 2, that is 100. So we have obtained gain A. So now the rate of change of output will be what? You differentiate this equation, so that is A Vin in Vm into omega cos omega t. So for distortion free output, remember this is the expression of frequency. A frequency should be less than or equal to this. So here frequency is given, so you can simply put F here, you can put SR here, that is slew rate. You have obtained gain A, so we have to find Vm. So directly I can switch over here. Vm will be equal to, you by putting these values, you have the amplitude should be less than or equal to 79.57 millivolt. So that means maximum value of amplitude in the input or amplitude of the input signal for distortion free output is this much. So I have given you the expression of frequency. So we are able to find the maximum value of the amplitude of input signal so that there is no distortion in the output. Fine. Let us see another example. The op-amp has a slew rate of 62.8 volt per microsecond and it is connected in a voltage follower configuration. Remember, voltage follower configuration means the configuration with the unity gain. We will see it at later stage, but you should remember at least at this moment you should remember voltage follower is the circuit which has unity gain. If maximum amplitude of input signal is 10 volt, then find the maximum frequency at which slew rate limited distortion would set in. It means just introduction of the distortion. So we have to find that, not maximum, rather minimum frequency. That will be the maximum frequency at which there is no distortion, or we can say minimum frequency at which distortion will be introduced. Fine. So we have seen maximum expression of maximum frequency, that is nothing but this. So I have written that expression here. For voltage follower, A is equal to 1. So simply by putting these values, you are, for unity for A is 1, Vm is given to you, that is 10 volt, SR is given to you, that is 62.8. So by putting these values, I have maximum frequency at which there is no distortion, and that is the minimum frequency at which the distortion will set in. Fine. Now let us see another example. An op-amp that is powered from plus minus 5 volt supply is used to build a non-inverting amplifier having gain of 15. Fine. The slew rate of op-amp is 0.5 into 10 to the power 6 volt per second. Normally slew rate is given in volt per microsecond. So here it is given in volt per second. For a sinusoidal input with amplitude of 0.3 volt,
the maximum frequency used up to which it can be operated without any distortion. Of course, we have seen output is A into V in, maximum rate of change of your output is this, although we have derived all these expressions. So or simply by putting in this expression, that same formula, you can remember this formula, or you can derive the expression by using these steps. So we will be able to find the frequency f should be less than or equal to, so maximum frequency at which there is no distortion is 17.68. so there is a correction here, it should be 7 rather than 6. Fine, you can just verify the calculation. So these are few examples based on slew rate. Of course, you will find a lot of numericals given in your textbook that will be uploaded on the website at later stage. For the time being, just remember these concepts and formulas. So in next video, I'll be talking about the characteristics of an ideal op-amp. That will be important for objective type questions in engineering services prelims especially, and in different PSU exams. So wait for my next video. Thank you very much for watching the video.